Road to Olympiad.
Welcome to RTO. Consider the following problem. Find all integer solutions xy of the equations x cubed plus x plus 1 cubed plus x plus 2 cubed until x plus 7 cubed is equal to y cubed. There are a few nice observations can be made here. First, as always, we are looking for integer solutions, so some number theory concept may be useful here. Also, we have the sum of cubes, so the sum of cube formula may help us in simplifying the sum. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by letting px be equal to the sum of x cubed until x plus 7 cubed. Recall that the sum of cube formula from 1 to x is given by x squared times x plus 1 squared, the whole thing over 4. And we have px can be written as the sum of cube from 1 to x plus 7, subtracting the sum of cube from 1 to x minus 1. Applying the sum of cube formula, we have this one, which we can expand into this, and upon subtractions and simplifications, we get 8x cubed plus 84x squared plus 420x plus 784. Since we are looking for integer solutions, let's consider the cube of some integer to look for the value of y. Notice that for x greater than or equal to 0, we have px is greater than 2x plus 7 the whole thing cubed, which is equal to this one. Because we can see that they have the same coefficients for x cubed and x squared, but px have a greater coefficient for x and the constant term. Also, px is smaller than 2x plus 10 the whole thing cubed, which is equal to this one for the same reason. Since px is between 2x plus 7 the whole thing cubed and 2x plus 10 the whole thing cubed, we have y can only be 2x plus 8 or 2x plus 9. However, if y is equal to 2x plus 8, we have px is equal to 2x plus 8 the whole thing cubed. This gives us negative 12x squared plus 36x plus 272 is equal to 0, which we can easily check that this equation have no integer solution for x. Similarly, if y is equal to 2x plus 9, we have px is equal to 2x plus 9 the whole thing cubed, which gives us negative 24x squared minus 66x plus 55 is equal to 0. Again, this has no integer solutions. Therefore, there is no integer solutions for x is greater than or equal to 0. Now, notice that p negative x minus 7 is equal to negative x minus 7 the whole thing cubed plus negative x minus 6 the whole thing cubed plus negative x minus 5 the whole thing cubed until negative x cubed. We can factorize the negative out of those cubes and rearranging the expression in the brackets, and we have this is equal to negative of px. This is to say that if xy is a solution for the equations, then negative x minus 7, negative y must be another solution as well. But since there is no solution for x greater than or equal to 0, there will be no solution for the case x is less than or equal to negative 7 as well. Knowing that there is no solutions for x greater than or equal to 0 as well as x is less than or equal to negative 7, we must have x is between negative 6 and negative 1 inclusive. There are only 6 possibilities here, so we can work them out one by one. When x is equal to negative 1, we have y cubed is equal to the sum from negative 1 cubed until 6 cubed. This gives us 440, which we have no integer solutions for y. When x is equal to negative 2, we have y cubed is the sum from negative 2 until 5 cubed, which is equal to 216. This is equal to 6 cubed, and thus we have y is equal to 6 in this case. When x is equal to negative 3, we have y cubed is equal to the sum from negative 3 until 4 cubes. Here, all the terms are cancelled out except for 4 cubes. So we have y is equal to 4. When x is equal to negative 4, we notice that this situation is just the same as when x is equal to negative 3. Just that this time, we have the sum is equal to negative 64 and thus y is equal to negative 4. Also, when x is equal to negative 5, the result is similar to that when x is equal to negative 2, which we have y is equal to negative 6. Whereas when x is equal to negative 6, we have no integer solutions for y. Therefore, there are only 4 solutions for the equations, which are negative 2, 6, negative 3, 4, negative 4, negative 4, and negative 5, negative 6. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.